Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
This episode was sponsored by the PVS Studio team. It promotes static code analysis methodology in general and its PVS Studio tools in particular. Static code analyzers allow you to find bugs in source code at the development stage. This helps to reduce the price of fixing them.
PVS Studio performs code analysis and issues warnings on the fragments of code with a high probability of having bugs and potential vulnerabilities in them. The tool supports C, C++, C#, and Java, and it can work with Visual C++, GCC, Clang compilers, and some of those used for embedded systems. The analyzer works on Windows, Linux, and Mac OS. PVS Studio can both be used as a standalone tool and integrated with Visual Studio, IntelliJ IDEA, SonarQube, and so forth.
In the show notes, you can find links to the PVS Studio website and the article Technologies Used in the PVS Studio Code Analyzer for Finding Bugs and Potential Vulnerabilities.
If you're writing code these days, you probably have to deal with the web. You may be building web pages, writing APIs, or consuming APIs written by others. Eventually, you'll run across HTTP at some level in whatever you do. Unfortunately, a lot of developers don't really seem to understand why HTTP is the way it is. And what we're going to do is try and correct that misunderstanding in this episode. But before we get started, Will, what have you been fighting this week?
Well, I am writing a Chrome plugin for a client, and it is stupid easy. I've written plugins for other things in the past, and so like if you're using managed languages and all where there's not really a good concept of like a plugin model built in, building your own plugin system is nasty, right? But with this, I mean, it's just HTML, JavaScript, and CSS, and then a little manifest JSON file. It's not bad at all, which is nice because I overestimated how long it was going to take, and I underestimated some other things on the project, so it all evened out.
Nice.
Yeah, I'm still digging the 100% remote, although now I'm trying to get my office kind of like I want it, and I keep finding little things that annoy me. This happened to me before too. So I keep moving stuff around. Like I'm going to have to move the microphone again. I moved it today and it still doesn't quite reach my face. I've got to figure out what I'm going to do. So in other news, and I know you have something similar as well, I am extremely sore. I did leg presses with 400 pounds. I did a bunch of leg exercises. And because my wife was jogging upstairs at the Y, I was like, well, I could just kind of like hang out or I could, go and walk and run. And so I alternated running a lap and then walking a lap. And I don't know how far I ended up going, but I was up there a really long time. And I was okay until after the first time I sat down. So like when I got to the car and then got out, it was pretty bad. So like my legs are still kind of hosed, and that was Monday.
Yeah, I totally get it. So over the summer, I have been doing hashtag hiking for leg day, where instead of doing leg day, I go hiking, and I hike like really hilly up and down. So it is a good leg workout.
Well, actually, I don't know where you go anymore. I know where you used to go.
Yeah, and it's about the same. Maybe a little hillier.
Yeah.
Not as long a trails, but it's pretty hilly. Anyway, it's not the same as a leg workout, but that was last week. This week, I am sore because I was at the gym and I saw my girlfriend over working out with the kettlebells. So
you had to go over, didn't you?
I had to go over, and we've had him on the podcast, David Whitley, who taught us both how to swing kettlebells and do other things with them, Turkish get-ups and stuff like that. So, of course, I had to go over and be impressive, and it's been a while.
Turns out the impressive takes a minute to come back on, doesn't it?
Well, no, I could do all the stuff.
Okay, good.
I did a Turkish get-up with a 30-pounder, which was the heaviest they had, which it's almost 16 kilos. So, like, I was doing double-handed swings with 30-pounders.
In each hand?
Yeah, in each hand. That was the heaviest they had. I'm like, really? But
yeah, I know. That's one of the things I don't like about a lot of places that have kettlebells is they don't have real kettlebells.
Yeah, but I was doing that. I was doing some, just fun stuff, showing off. And I'm a bit sore from that.
You
That's
got, didn't you?
yeah, I did it to myself though. I did it to myself. Did you hear that Google Bulletin is going away?
I saw it in the outline.
Yeah.
Yeah, the only news I've read about Google was on the BBC this week, and I read it in Russian,
Yeah.
and it took me like 3 hours. So,
Yeah. I got an email from them because I posted some stories about some of our events and stuff. And I just wonder because we had the Google developer come and talk to our meetup group in Nashville about progressive web apps. And I'm wondering if it's an issue with just progressive web apps not being a thing, or if it's just that no one really used Bulletin. It just wasn't a good social media idea, or it might not have been a good time for it.
yeah, I think Google's had a pretty hard time, sticking the landing as far as social media anyway. I mean,
Yeah.
with Google Plus and all that.
Yeah.
They seem like they're more of a ad type thing versus a social platform. So it doesn't surprise me.
That makes sense. Also, took my first test in discrete. Didn't do too bad. I got an 88 on it. Not bad for the first math class I've had in almost a decade. It's a lot of work. I'm enjoying the class. And honestly, I would have had 100 on there had I not made two silly, stupid mistakes. Just like dumb stuff that further questions built on. And I missed them because I had messed it up higher up on the test.
I hate it when they chain them like that.
Yeah. It's not like I lost all the points, but there was one where I did lose all the points because when she saw the equation I put in the wrong equation. But if I had solved it for that equation, I would have gotten it right. But because I solved it for the right equation with the wrong one, like with the wrong premise, that's why I missed that one.
Yeah, bummer.
It's like, if you had solved it with that premise, you would have gotten it right. So it's completely fair. I deserved the 88 because of the mistake I made. But no, I'm really enjoying it. I'm getting a lot out of the class. It's a lot of fun. The other day, some people had some issue watching one of the pre-class videos, and the professor said, she's like, I tried it in my office and it worked. I tried it here and it worked. I can't repeat the error, so I can't fix it. And I couldn't help myself. Normally I'm pretty quiet in the classroom, but I just popped out with, you're going to be saying that the rest of your career. She chuckled and she's like, yep, y'all get used to it.
Yeah.
Speaking of the rest of your career, let's go ahead and look at some algorithms to live by in book club. So the next few chapters in the book, Algorithms to Live By, The Computer Science of Human Decisions, talk about caching, scheduling, and Bayes' rule. In chapter 4, the authors start off by comparing memory storage problems to having an overfull closet. They go on to explain the history of caching in computer science and apply it to areas such as organizing a task list or how to set up a library for optimal usage. This leads right into scheduling in chapter 5 and the science behind how we spend our time. They even go into the history of Gantt charts a little bit. In chapter 6, they get into Bayes' rule and predictive algorithms. It's a pretty neat book, and I like how they are taking these computer science concepts and algorithms and math problems and applying them to the real world.
Yeah, I kind of wish a lot of this stuff that I was taught in Meat Space first instead of in an algorithms book, because a lot of it's really common sense if you can think about it outside of computing.
Yeah.
So
it really is. I really recommend this book, and I'll have a link to it in the show notes. Who's talking to us this week?
Well, we got an iTunes review from, I hope I get this right, Ramesh Don. Very actionable discussion. This podcast is very actionable and enjoyable. Love Will and BJ's love for what they do.
Well, thank you very much. We love creating this show. It's a lot of fun. We have a blast doing it. Honestly, it's basically the two of us sitting around geeking out, and we just put microphones in front of our faces and, publish it with a little bit of editing.
Yeah, just a little bit that you don't have to do anymore.
Yeah, used to be a lot of editing, but we've gotten a little bit better about it. But send us an email to waterbottle@completedeveloperpodcast.com with your contact information. because we've got a complete developer water bottle just for you. Guys, if you'd like your very own complete developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, LinkedIn, and Twitter. We're also on Instagram and Tumblr. Or you could join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Most of us will have to deal with HTTP at some point in our career. Understanding the web and its underlying protocols is absolutely necessary for understanding most larger systems that are in use today. While you can get by with a little understanding of the protocol for quite a while, at some point you will have to really dig in and understand not only HTTP as currently implemented, but the history of the protocol. You'll need to understand why things were done the way they were years ago and how those things were overcome in more recent iterations.
So, according to Wikipedia, the Hypertext Transfer Protocol, or HTTP as we'll be calling it throughout the episode, is an application protocol for distributed, collaborative, hypermedia information systems. Basically, it's a stateless application layer protocol for retrieving resources from and sending resources to web servers. It's basically your communication to and from a web server.
Yeah, it's how to make the web server talk, to really take it down a notch.
Mm-hmm.
So I got a little bit into the history. And then when I wrote the rest of this outline, I realized that I didn't have time for a long historical discussion on HTTP because of all the other stuff. I learned a fair bit in here, and I've been doing this for a very long time. So development of HTTP was initiated by Tim Berners-Lee at CERN in 1989. Again, this comes from Wikipedia. HTTP 1.1 was first documented in an RFC in 1997 with another RFC in 1999. Kind of took them a little while to get that done.
RFC?
Request for comments.
Okay. HTTP 2 was published in 2015. So big bit of time there between 1 and 2. Kind of like JavaScript.
Yeah.
And that made HTTP's semantics more efficient on the wire.
Yeah. And so there was some discussion that HTTPS was slower than HTTP, when you have the secure layer in there and you have all the decryption and all that going on. But apparently in version 2, it's actually faster with the encryption because of something with the way the wire protocol works. And I haven't dug into that enough. Just people I trusted said it's faster. And I haven't run into a situation where I needed to actually prove it. So That's what I know. And then the next thing is, HTTP 3, which is, coming out eventually. And it's looking like this one is going to switch. So instead of the transport channel being TCP, it'll be UDP.
I have heard that.
Yeah, which is interesting for situations where you have intermittent connections or connections where the connection speed slows. Because you know how TCP does that little handshake to determine the speed?
Mm-hmm.
I think that's a way to get around some of that and some of the other overhead to say, yes, I got this packet.
Real quick, I just thought about this. We didn't define what is UDP and TCP for people.
Okay, so both of these are transmission protocols. I'm going to forget which layer they are in the network stack. The gist of what you got to know about UDP is that when a machine sends another machine a packet, that second machine doesn't have to acknowledge the packet. It's just like, yeah, I got it. And so this tends to be used for things like gaming a lot of times, or sometimes like streaming video, those kind of things where it's already chewing up a lot of bandwidth. And so this cuts it down. Whereas TCP is more of like, hey, I'm sending you a packet. Okay, send me a packet. Okay, here's the packet. Okay, I got the packet. Okay, I acknowledge you got the packet.
I think we've had an episode talking about these.
The networking stack, the 7-layer burrito of networking.
Yes, I remember that one.
Which we probably ought to go really into the weeds on TCP at some point as well. But
that was really good. I mean, that was a great explanation of what they are. What I was looking for was what the acronym stands for. So TCP is Transmission Control Protocol, and UDP is User Datagram Protocol. That's just something you can look up and go deeper into. Also, check out the 7-layer burrito of networking episode, because that was a really good episode.
Yeah, well, and I gave you the breakdown of what they were because I couldn't remember what the acronyms meant off the top of my head. So
I know when you started doing that, I knew exactly what was happening. So I just Googled them really quick so that I could know, because I'm like, I don't want to say it wrong. I thought I knew what they were, but I'm like, I don't want to say the wrong thing.
Yeah, and that's kind of what I thought too. So it's good that the shared brain cell was working for both of us today.
That's true. That's true.
Let's get into some definitions because you're going to need these as we get a little further into HTTP and understand all the pieces that are going on. So, a request is a packet of information sent from a client, typically a browser, but not always, to a web server.
Now, a response is the payload that a web server sends back to a client when it gets a request.
Right. This can include errors. It's whatever comes back. Now, the next concept you need to understand is a user agent. A user agent is a piece of software acting on behalf of the user. It's typically the browser, but not always. The other thing you can do is you can mess around with a user agent string and see the output that a web server would give to a different browser. So, for instance, Google's web crawlers will do certain user agent strings, and people use those to let the crawler into certain areas of the site that they won't let, like IE in, for instance. Pinterest, I think, does this.
That makes sense. Another thing that a user agent could be is another web server. I know I have worked with APIs where you call an HTTP protocol to the other API.
Yeah, are you forward? Because I'm actually doing that in some of my day job stuff now. There's a web service that I have to access over VPN and then like mess with the data a little bit and then ship it on. And that's exactly what I'm doing. I'm serving as a proxy for these calls.
Yeah, I've seen that. I've also seen where like you have certain things like talking to the database and talking to internal services happen behind a firewall, but then you have an API in front of the firewall.
Yeah,
that is like the only thing allowed to cross the firewall is that API. So it's a security thing. I've seen those talk via HTTP as well.
Yep.
Next is URL or Uniform Resource Locator. So good. You had the definition or the meaning of URL. That was good.
Yeah, sometimes I do it right. What that does is that indicates how to get to something on the web. It's essentially an address. Well, we call it an address anyway.
Yeah.
If you hear the term web address, that's that.
Mm-hmm.
Now, the next piece you need to understand is headers. And what headers are on a request or on a response is a set of key value pairs that are sent to the server or received from the server, oftentimes both. And they aren't part of the content. So it's not like the HTML that comes back, for instance, it's above that in the stream of stuff that comes in. And that basically tells the web browser how to react to what's going on in there. So stuff like setting cookies, all that kind of stuff. We'll get into that here in a minute.
Next is the HTTP verb. And this basically indicates the intent of a web request. So, what are you doing? Are you getting something? Are you putting something? Are you leading something? And we're going to dive deeper into each of those and the others. Next is a cookie, which Will has already mentioned before. And this is, not the chocolate chip or snickerdoodle, which is my favorite if anyone wants to send me cookies. But instead, it's a small piece of data that the server sends to the client and vice versa. It goes back and forth that is maintained for the client as long as the client session lasts.
Yeah. And you notice before this, we didn't, really get into what a session is. A session is the server-side storage of information that should persist for the period of a user's interaction with a website. Now, this is a little weird because HTTP is stateless. As a result, the server doesn't know that you've disconnected ever. And so sessions have timeouts and all those kind of things going on with them. The data is just there for some length of time, whatever that happens to be.
Yeah, and this is not the same as that underlying TCP session.
Right. That complicates things even more, right? That's just fantastic.
Finally, a cache is a store of the response to an HTTP request. This is intended to lighten the load on the server by keeping requests from going to the server when there's no need to do so. Really interesting because when I was looking at this, I saw, you had mentioned caching and stuff. And I was like, oh yeah, I remember I just revisited that chapter in the book that we're going through in book club, because it had a lot of good information about the history of caching just in general, the concept.
Yeah. And caching is a whole nother point of complication. And this interacts, by the way, with your HTTP verbs and your headers and the response as well. Because, if you're doing a GET request, right, those tend to be cached more. You don't usually cache the results of a post.
Yeah.
For instance. Although Safari on the iPad like 8 years ago was doing that, and it was a real nightmare.
Yeah, I remember that.
Yeah, you remember all the profanity from that one. That was the job I was working at when I went to your wedding.
Yes.
I remember telling you about it, and you're just like, dude,
Yeah.
good luck.
Yeah. So we're going to use these definitions throughout the rest of the episode to talk about HTTP. The first thing we're going to talk about is the request and response cycle. While this process looks simple, it gets complicated rather quickly.
Yeah. So when you type in to your address bar on the browser, the first thing that happens is your web browser will look and say, okay, let me get this domain. Let me go find it. So it has to look up the IP address of the server. And this gets into DNS, which we probably ought to also have an episode on someday. But essentially, there's a lookup process that happens that's multi-step. So your machine has a DNS cache, your router probably has one, your ISP has one, other DNS servers have them. There's all kinds of layers that could be in here. If the IP address is cached, the browser moves on to the next phase. And with the multiple layers, that's more than likely what's going to happen if you've ever been to that website before. But if not, the browser has to look that up. And that process is a lot more complicated. You know, it keeps stepping back through the layers until it finds somebody that can tell it who that is.
Yeah. Now, once the IP address of the server in question is retrieved, the web browser opens a TCP connection to that server. A TCP handshake process occurs as the server and the client negotiate the connection. It's a handshake. It doesn't fully describe it. I know it's used throughout the industry, but it's more like
It's like a ballet in the dark.
what I was going to say. It's more
Yeah.
like those goofy handshake, like secret handshake things that we did in middle school with our friends. Where it's like slap and punch and elbow and just like it's all this stuff back and forth and like give and take to establish that connection.
Right. Yeah, that's a really complicated process as well. And basically what this does is it opens a connection so that the subsequent HTTP traffic can run on top of that TCP connection. Now, I don't know what they're going to do with UDP under there. And frankly, I'll read about it when it comes out. I'm not that interested right now because it's just not my problem. Yeah, I hate to be that way, but I don't really hate it that much.
That makes perfect sense.
Yeah. After all of that, all those shenanigans get done, the next thing that happens is the browser will package up an HTTP request and send it across the transport channel. So if you're typing in your web browser, you type an address in that's typically a GET request. There's ways you can make a post, but you don't do that from the address bar.
No.
I think you could probably cram some JavaScript in there and force a post. Somebody's going to be able to do that now, but typically you don't. And so it's got that verb. It knows the address. It knows where the server is, and it builds up a request that's got your user agent, all the stuff that it needs to know, any cookies that maybe are still set for that domain if you've got it, and sends it on.
Yeah. Now, once the server receives that request and it verifies it through whatever process it's doing, does whatever server-side stuff needs to be done, if that's talking to a database, if that's calculations, whatever it needs to do to process the request, it builds up a response in the format that's requested. So it could be HTML, JSON, XML, all sorts of stuff.
Yeah.
Mostly you're going to see HTML and JSON. Sometimes you'll see XML.
Yeah, and sometimes you'll see even weirder stuff.
Yeah. But most times, and most REST APIs are going to return JSON from what I've noticed.
Yeah.
Or at least the ones I've worked with.
Yeah, you weren't around for all the web services nightmare in the early 2000s where it was like,
no,
just keep throwing more XML at it until it stops resisting. It's just like, yeah, I mean, the way we were treated with web services, XML was like a prisoner being beaten until they confess. It was like, oh, it's not doing what we want, throw more XML at it until he just gives up.
Yeah.
Early 2000s were pretty rough on that. So the server sends out a response, whatever that happens to be. And this includes not only the payload, but there's a response code and all that kind of stuff in there.
Mm-hmm.
The response will also indicate to the browser how to handle caching, what cookies to set, privacy information, all that kind of stuff. The browser then is expected to actually follow that, which may or may not happen, but it's a nice thought.
Yeah. And then it's going to display the HTML content that is returned. Or if you're using something like Angular, that's going to be sitting on the browser. So it's going to display whatever JSON comes back or XML comes back, however your service is set up like that. We're not talking about specifics of services this episode. We're talking about how they talk to each other.
Right. Or one way, at least.
Yeah. So next, we're going to discuss understanding the structure of a URL.
That's the other fun one, right? This follows the structure of a URI, or Uniform Resource Identifier. I really hate that those acronyms are so close together.
The problem is they're not only close together, but
they're deeply related.
Yeah, and people use them interchangeably.
Yeah.
Even though they're technically not.
Right. That's another pet peeve of mine, but there's some pieces to this thing. First piece is called the scheme, and that's the first segment of the URL, and it's the part before the colon. So, if you will, the stomach of the URL.
Oh, man.
I had to say that.
An anatomy joke. Y'all, that is not in the outline. Normally, we put our jokes in the outline so we know what's coming up. That is not there. Oh, my. That's good. I thoroughly appreciate that anatomy joke. That's good.
Thought you might.
So, this is like your HTTP or HTTPS part.
Yeah.
After that comes the authority segment, which has a few pieces. The user info component is optional and precedes the host. This may consist of a username and password separated by a colon, followed by an @ symbol. I've not seen this.
You'll see this in FTP addresses.
Okay, yeah, I have.
Username, password. It's the same scheme. It's just like, I can't think of when I've seen it in HTTP, and I've been around a while. Let's just leave that.
Yeah.
So the next piece is the host subcomponent, which is either the name or the IP address of the server on which the resource resides. So sometimes you may just hit a server and it may be by IP address. You typically don't see this a whole lot. And in fact, a lot of web servers actually use that host name to figure out which website to go to. But if there is a default one at that IP address, then it'll go there.
There's also an optional port component, which is after the host segment and separated from it with a colon.
Right. And so a lot of times you'd be setting up if you're running localhost, for instance, right? You're doing debugging, you'll be doing localhost and then some port.
Yeah.
You're not going to see this out on the web normally unless you're debugging most of the time.
Yeah, that makes sense. Following the host is the path, which is the address of the resource on the host. This will be encoded as UTF-8, and you can look at our earlier episode about strings. That's a very earlier episode.
Yeah, because we don't want to get into it again here.
We don't want to get into it again if we don't have to. That's an old one too, y'all.
Yeah.
Sorry for the audio quality.
Yeah. But, I mean, it's good stuff.
It's good material, yeah.
Yeah. So any characters that are not part of the basic URL character set are escaped as hexadecimal using percent encoding. So, for instance, a space is %20 because a space is character code 32, which is 20 hexadecimal.
Yeah, that makes sense. And you'll see this for quite a few things, and it can be interesting when you have to translate in your code into and out of a URL.
Yeah, because there's a function for that in the browser that can, kind of do some of that unpacking and stuff. But
I was actually referring to in your API code.
Oh,
when you're creating them, depending on your framework and your language. Like in .NET, we have the ability to just pass something in and create a URI, which will do that for this. But in some languages, you may not be able to do that. And so you have to think about that and make those conversions.
Yeah. So there is one other thing, and I just throw this out here because you'll hear this. Sometimes the last segment of the path is referred to as the slug. So like, for instance, on our WordPress website, if you go to any of our episodes, the last little bit is /episode - and then the episode number. That's the slug for that. That's a publishing term, but you'll hear it because it's slipped into tech just enough that it shows up sometimes. So just putting that in there.
So after the path is an optional query component, also known as a query string.
Right.
If this exists, it is preceded by a question mark. And the query part of the URL is a set of key value pairs separated by ampersands.
Yeah, and this isn't really well defined, but this is the convention that most people use. So if you see something that breaks this rule, it's not my fault. They're just being weird.
So I know in .NET, when I'm building a web API, I can set it up if you have multiple. It's usually in a Git where you would pass multiple things in the URL.
Like a search string or something like that.
Yeah, that search string would be great for this, but I usually pass those in as posts. I don't know why. I just do because they're pretty big.
Yeah, because they're big and you want to put it in the request body.
Right. The other thing is if you have like multiple things you're passing in the request URL for a Git.
Yeah, you make them part of the segments of it.
Yeah, you can make them part of the segment. So like it would be like /ID/ user ID / whatever. I don't know, like whatever multiple things you would want. Or they could pass it in with this.
Yeah, I tend to use the / based one, with the parts if all the parts are non-optional. And then the query string is if some of the parts are optional or not. And so you're switching.
Yeah.
Because it's a key value pair and it might not all be there. That tends to be the way I break that down. I don't know that I actually ever actively thought about that until we had this conversation just now, but that's what I do.
No, I really like that. I'm going to start doing that from now on because if I have an optional one, I put it in as the last one. And I haven't known how to do multiple optionals before.
Yeah.
But forcing this pattern for that would work. That's really good. Awesome.
Yeah.
I like learning stuff.
Me too. I didn't know I did that until we talked about it. And I mean, I probably just got that from somebody who actually thought about it.
Yeah.
Like Joe Audette, he won't mind his name coming up on here. Probably taught me that at some point that I don't remember. Now, additionally, there may be a fragment component, and this is preceded by a hash. You tend to see this like in really rich client type things. So I think Angular does this in certain cases, and you'll also see it to reference elements on the page. So you can anchor stuff, and you can use like a table of contents, and you click, and it just jumps down to that part without navigating.
Most of your spas will do this.
Yeah.
To pass in like where.
So it'll go in the browser history.
Yeah.
That's the main thing. So you can get back to where you came from. Mm-hmm. Because we all know that the single page app will load again next time, just like it loaded this time. Right. I have deep faith in that.
So on that, now we're going to talk about something we've mentioned earlier and we said we were going to talk about. See how we do that? We say we're going to talk about it. We talk about it.
Mm-hmm. And then we tell you what we talked about.
Yes. The HTTP verbs.
Right. And so there's a few of these that you'll run into. I don't know for sure that there's actually a restricted set, but there's just like a convention and these are the ones you'll see. The first one is the get, and I'm kind of relating these to SQL because it is a similar expression of intent, except when it isn't. So just bear with me here. So a get is very similar to a select in SQL. It's like, hey, give me this thing. Don't change the thing, but give me the thing. So you shouldn't put destructive or data alteration things behind a get because it gets cached like crazy and it's just not good calling semantics, essentially.
That makes sense. I didn't think about the caching. Because I knew not to do that, but I was asked, well, why can't we just pass this in via Git? I was like, because it's code smell. It's a bad idea. I don't know exactly why.
It's an abomination before the Lord.
Yeah, something like that. But
did you really use that as an argument? That would be great.
I did not use that as an argument. No.
I have.
But I have people who trust me enough where I work to where if I say, hey, I can't explain why, I just know I have been told not to do this.
That's why.
I will eventually learn why. And now that makes sense. Now I can go back and say it's because of the way that Git's cache. Imagine if you tried to do a delete where you just did a Git and you passed in the row ID from the database. That's all you really need to do a delete.
Yeah. Or you're periodically hitting an endpoint and every time you hit, it's hitting an account to say, okay, they're using the app. And so it's time-based and it's cached it. And so you don't get to bill for a bunch of time that got used.
Oh, that's brilliant too. I didn't even think about that.
Yeah. Just don't do that.
Yeah.
That is a bad time waiting to happen.
Mm-hmm.
So opposite of the get, or the other one that people really use a lot, and up until recently, there were reasons that some of the other verbs didn't get used much, is post. Now, post tends to be kind of sort of similar-ish to insert in SQL. In practice in the field, you're going to see a lot of implementations that treat this verb more like an upsert or, where you're doing search through post or those kind of things because of some of the vagaries of HTTP.
Yeah, y'all can't see me raising my hand. I do some of this stuff just because it's easier and it's not the best, but
Yeah, the other thing too, like there was a point in IIS where you could only do get and post on most servers. You couldn't do put, patch, delete. And so what you would do is you actually passed a special header that the framework would interpret and switch the thing over
huh.
somewhere down in the guts. And
Oh,
it was
wow.
like, why don't you just make it work like the web works instead of hacking it? Like, why are you doing that? And then all these, Ajax calls got in the mix and they're like, yeah, we can't continue to be dumb. And so
Yeah.
they fixed it. There was a time there that was a thing.
Yeah.
And it's been 15 years.
Yeah. So a put is used to replace a resource. So this, instead of an insert, would be an update.
Yeah.
If we're comparing it to SQL, it would be like an update because the resource exists and you are replacing either the resource or a component or part of the resource.
Well, that's where it gets weird, right? Because the next one is patch.
Patch. I know.
So put is like, I'm out of ketchup in the pantry. So replace the empty bottle with this full one.
Yeah, you're replacing the entire thing.
Yeah, whereas patch is like fill it back up.
Yeah. So what it is put is take what's in the database and replace that row with this information. Patch is, hey, update these columns in that row.
Yeah, and it's kind of weird because it's not based around the database. And so
it's not.
Think about like a document database more than a table based.
Yeah.
Where you have a hierarchical structure, you have a chunk of JSON or something, and put would be like replace this document, patch would be like overwrite this part of the document. It's
No, I get you there. That makes sense. I've used put. I've not ever used patch.
I've used both fairly recently. The really weird thing is what happens when the semantics change and it's like, hey, I'm not doing just a put now, I'm doing a patch or vice versa. And now the caller has to be aware of that. And that feels like implementation leakage. And I don't like it very much.
Yeah.
But whatever. Now, the last one is delete, which does exactly what it says. It gets rid of the resource. And that's obviously very similar to delete from SQL.
Yeah. That's pretty straightforward on that one.
Yeah.
A delete deletes.
Yeah. I mean, it's like I had to use an analogy and I had to find something that wasn't just awful. And that wasn't, it just wasn't great.
All right. So now we're going to look into HTTP headers. Headers might apply to both requests and responses, or they could be part of only one. And there are also entity headers, which contain information about a resource, such as content length or MIME type, things like that.
Yeah. So if you're getting a binary back, you need to know, hey, what image format is this so that I can actually render it? Because otherwise you got to be really smart about detecting that. And sometimes that doesn't work all that well.
Yep.
So headers consist of the case insensitive name of the header, followed by a colon, and then the value of the header. Now, you're never going to see this in your web browser unless you look at DevTools and they make it display nicer.
Mm-hmm.
There are far too many types of headers to discuss here. So we're just going to break them down into some categories, and then you can research them further if you need them, because I looked at the list and there were a lot of them I have never needed. So I don't know.
Yeah. First off is authentication headers, and they indicate how to get access to a resource. These may contain credentials and things like that. Would this be where like your JWT tokens?
I think that's correct. I think that's where they float through. I actually need to go look at that tomorrow for this other thing I'm doing at work, but I believe that's correct. Yeah.
The last thing I was doing before what I got moved to now was working with JWT bearer tokens, and I know they're passing through the header. I think it was an authentication header. I know OAuth 2 would be there.
Yeah.
Next is caching headers, and they indicate how a resource should be cached.
Right. So this will have stuff like your e-tag and some of those things to say, hold on to this thing for this long, that kind of stuff. The next one is client hint headers, which indicate suggestions to the client for how to handle the payload. So this could be things like the viewport width, those kind of things. I've never had to interact with this stuff. I assume that something under the hood probably handles it in most of the cases that I've had to deal with.
Interesting. It's like I've used CSS for like dealing with different screen sizes. So like mobile versus tablet versus desktop. Could you use that here?
I don't know. This is coming from the server
Yeah, that's what I'm saying.
to tell the client how to render. So I'm just not really sure.
Could the server tell the client, hey, if it's on mobile, render it this way versus if it's on.
Yeah, but they already have primitives that work better for that. So like that's the thing is
Yeah.
I've never really interacted with those that I can think of.
Okay. I was just curious because that's what it made me think of.
So the next one is conditionals, and these are usually on the request and indicate whether to return the resource or not based on a condition, such as how recently it was changed. So you can say, hey, if it hadn't been changed in the last 10 minutes, don't give it to me.
Ooh.
And there's some stuff around caching. I don't know what is actually exposed in the JavaScript libraries that you and I use for that.
Yeah. Connection management headers indicate how long the underlying connection should be kept open after the current connection completes.
Right. And so you can do some load management on servers, for instance, to say, okay, I know that when they're hitting this, intensive process that the connection just needs to stay open for a minute instead of reestablishing later.
Mm-hmm. Yeah, I follow that. There's a couple of things that we've done where we've had to be like, all right, you're connecting for this one thing and then reconnecting for another one. So you might as well maintain that underlying connection and then pass it. Yeah. No, I follow that. Content negotiation headers tell the server what type of data to send back, how it's encoded, and what language to use.
Right. So you can say, send me JSON.
Mm-hmm.
Or you can say, send me XML. Like a lot of APIs, you can do either, and it just is serializing an object and handing it to you. So the API doesn't care. It just tells it what serializer to use. It's the other thing with language. So you could say, hey, I'm, send the thing to tell me that I'm using Russian. I've had to do that on the BBC site before so that I could read that stuff. Cookies indicate which cookie values are set on the request and which ones should be set on the response. So you're obviously passing enough information back when you make the request to say, hey, this is my session.
Mm-hmm.
Here's the cookie values I have set. So sometimes client-side stuff may be messing with that too, or other things.
CORS headers indicate policies for how content is accessible. For instance, you might have a policy that indicates that certain content is only accessible from certain domains so that other parties don't misuse your server.
Right. So you got an API and you can say, hey, this is only accessible to subdomains of this domain.
Yeah.
So that, Joe Blow out here can't hit my API and, peg my server out and run up my bill and I get nothing for it.
Yeah.
Unfortunately, the problem is you end up in a situation where the defaults hurt here.
Mm-hmm.
Everybody has a CORS story from the last month that was miserable. And nobody has a happy one.
That's so true.
So, and there's a lot more beyond these general, like I even tried to break it down into categories and there were too many categories to describe. There are a crap ton of different headers. So go look it up if you really, really want to know. The next thing you need to understand is HTTP responses, especially the response codes. This is what we really want to get into. So, you always get a code back that says, how this request went. So it can indicate, error conditions and those kind of things. Messages that start with 1 are informational messages. And because they're informational and they're probably instructions and stuff, we developers don't look at them. So we don't know.
That's true. I don't know anything about the 100s.
Like I can't call up one of those off the top of my head. And I looked at this last week, right?
Yeah.
So it may be important to you. It just isn't to me. So the ones that started, getting important are the ones that begin with 2s.
So 2s indicate success.
Yes.
Usually this is 200. Some others are 201, which is created, 202, which is accepted, and 206, which is partial content.
Yeah, and I think a lot of those other ones are handled by the browser under the hood. Like you don't do this with JavaScript. Unless you're writing a browser, this is probably not your problem.
Yeah, I mean, you're just looking for, is it a 200 level?
Yeah.
Did I get back what I needed?
Yeah, or you're writing something in Fox Pro that has to open up a TCP connection and you've got to manually do HTTP. Then you got to worry about it.
Yeah.
But, you've got other problems.
Yeah.
Like Fox Pro, for instance. Got some experience with that. It is not on my resume for a reason. Now, messages that start with a 3 are redirects. So this would be like 301, which is a permanent redirect, or 307, which is temporary.
All the 300s are redirects, but the two that are the most common are the 301 and the 307.
Yeah.
But basically, if it's a 300 level, it is a redirect. 400 levels are client-side errors.
Yeah.
So a 400 is a bad request. I like to do this if we have an API error. I'll return a 400.
instead of a 500s.
Yeah, because the thing is, if we get a 500 back, that means there is an error on the server versus an error in the API.
Oh, so it's about blame.
Yeah.
Blame-driven development.
Yeah, it's a matter of, is it a developer problem or an operations problem?
Yeah, I mean, so you have stuff like 400, which is a bad request. So this could be a malformed URL. This could be all kinds of stuff.
Another one is the 401, which I see a lot as well, and that is unauthorized. It basically means you don't have credentials. And because I was recently working on doing some authentication and authorization, then returning that has been important. Another one on that same note is the 403, which is forbidden. And that is, you have credentials, but they don't have access to this area.
Right.
I worked with both of those.
So it's like going to the airport. A 401 is I forgot my wallet and I don't have my driver's license. A 403 is I brought my library card and tried to get through TSA.
Yeah, that works. That works. The next one is a 404, which most of us, if you've been in the industry for any amount of time,
or had to use any website written by us.
Yeah, know plenty of 404 jokes about not found. This basically means what you're looking for isn't there. This is one thing I do return a lot. I return 400s, and 404s mostly. Because like 400, hey, you didn't give me the information I needed to get you what you want. Or 404, hey, what you're asking for isn't there.
Yeah. You also see 405s, which means that method is not allowed. So you try to get when this endpoint only takes a post.
Yeah, most of the time I get the 405, it's because I forgot to change something in Postman.
Yeah.
And y'all, there are a bunch of others. We have a website that we'll put in the show notes for you to go check that out. And we kind of hinted at it, but messages starting at the 500 level are server-side errors. Like I was saying, we use this to indicate, hey, it's an operations problem. We're not getting to the API because it's the server's returning this error before it gets there.
Yeah. Or the API is blowing up and throwing an exception because they can't connect to the database or some junk like that. So 500 is an internal server error. And you'll see this a lot if you do any API development.
Oh, yeah.
I ran into that with a service I was calling. These people did not tell me what the data format was. They're just like, here's the endpoint, call it. And I'm like, I'll pass a string and see what it says. And it said 500. Turns out that they really want this complex XML with like some other stuff jammed in a C data section that has to be formatted fixed width. It's awful.
That's ridiculous, man.
Yeah, pays good. It's like you get to a point with other people's systems that you're like, you've pretty much seen everything and it just doesn't bother you anymore. It's like being a doctor.
Yeah.
After a while, you're like, yep, you're the dude in the ER that you call the other staff in and go, hey, look at this X-ray. So yeah, it's just, that's life. Now you'll also sometimes see a 502, which is a bad gateway. So that means something upstream broke while processing the request. And a lot of times you're not going to be able to figure out what that is.
Mm-hmm. 503, which is something I've seen way more than I care to admit, indicates that the service is unavailable. This is just an annoying one to get because you're like,
is it me? Is it you? Is it somebody in between us? Is it somebody that you talk to?
Yeah, it's just like, okay. And again, like the 400s, the 500s, there's a lot more than we mentioned here. These are just the most common that you'll see.
Yeah, if you notice, there's kind of like, it's a little lopsided towards errors.
Yeah.
There's a reason for that.
So now we're going to talk about the HTTP sessions. And a session is essentially the server-side representation of the data that is required during the course of a user's interaction with that web server.
Yeah, and sessions are identified by a session ID, which is passed along with the request, along with other stuff too, because you've got to stop, things like man-in-the-middle attacks and all that kind of fun stuff.
Yeah.
And then it goes and looks up the data, and it's got the data on the server. So that's roughly what's going on there. Now, depending on the application, the amount of data stored in a session could vary a lot in size. You're not going to have to worry about it as a client at the server level. You do.
Yeah. Now, you also want to keep in mind that if your website uses a lot of servers, you'll need to be careful about how you manage sessions because you can no longer store the session on a single server if that's the case.
Right, because if you're hitting multiple servers and you don't have sticky sessions, that's essentially what they call it, where it stays on the same server. That's something people learn the hard way, usually at least once.
Mm-hmm.
I didn't because I'm so old. I remember when it started coming out. But, but it seems like it's a thing with newer people. They're like, well, why is this all screwed up? And you'll get weird stuff sometimes where, like, part of the session is there and then some other data is missing because it's jumping between servers. And yeah, it's like having multiple threads, except you don't realize you have multiple threads.
Oh, man, that's...
Yeah. You get those kind of errors, race condition type stuff. It's ugly if you're not careful about that.
I don't have to deal with it having things where I'm at, but I've heard about... No, that just doesn't sound fun.
Yeah. So speaking of not fun, the next thing to talk about is HTTPS. HTTPS is essentially a way of encrypting HTTP traffic. So this prevents man-in-the-middle attacks. This prevents snooping, those kinds of things. Kazakhstan had an issue with their certificates not all that long ago where, like, their government was reading everything because they had a root certificate, and we don't want to get into all that. But this is supposed to protect your traffic so that nobody else can mess with it or read it.
It also ensures that you're communicating with the server that you think you're communicating with by identifying the server. Now, the thing about that is it doesn't make sure that that server isn't sending you bad stuff. It's just you are communicating with the server you say you're communicating with. It secures that transaction, not the two ends of the transaction.
Scott Hanselman had a good way of putting this, and I can't remember the example exactly how he phrased it, but it was something to the effect of HTTPS makes sure that you're having a secure conversation. It doesn't make sure that Charlie Manson isn't on the other end.
Yeah, I think he said the devil isn't on the other end. But
okay, same difference.
I remember hearing that, yeah. So with this, a handshake process occurs. We've talked about that it's not a standard handshake. That's a middle school handshake.
This is a handshake on top of the other two handshakes.
Right.
So if you picture two octopi meeting each other, that's where we are now. Or it's the web, so it's actually two spiders.
Yeah.
And chorus is the poison on the fangs, obviously.
Basically, this enables the two parties to figure out which version of SSL is going to be used. So the server sends a certificate containing the public key used to encrypt data going back to it. The browser verifies the server using a certificate authority and then sends a certificate verify message to indicate that it accepted the certificate, followed by a change cipher spec command, which indicates the subsequent data will be encrypted.
The server then follows this by sending the browser a change cipher spec command to indicate that the data returned will now be encrypted.
The browser then generates an asymmetric key and encrypts it using the public key that the server sent and sends that to the server. These two keys are then used to secure the exchange of information between the browser and the server. That was a lot.
Yeah, HTTPS, and there's a lot more going on there as far as like the certificate authorities and all that kind of stuff that we probably should also talk about in another episode. I feel like every time we do a tech episode, it's like, oh, here's 15 other ideas for episodes that we could do. It's kind of never ending.
Yeah. That's why we have over 5 years of backlog ideas. So,
yeah.
Y'all, having some understanding of HTTP is critical to being a developer these days. Not only is HTTP used to send and retrieve data from browsers, but it's also a very common method of integrating applications. Whether you are building cloud scale AI applications, working on IoT devices, or simply writing a boring business code app, you are probably going to have to deal with HTTP at some point in your job. Even a rudimentary understanding of how the process works can help you significantly if you ever have to troubleshoot problems with it. While this episode wasn't a deep dive on the subject, even though some places felt like it, it's been a good overview to help you get a little bit more comfortable with it and give you some ideas of where you can look deeper yourself. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I want to point out all the error handling that's built into HTTP and suggest that that's probably a reasonable level for most of us for the apps we write, and that none of us do that, right? Because they have it built where it's like if anything fails between you and the server, you find out about it and you get a response that tells you kind of what happened and breaks down the error codes. A lot of developers will just throw an exception and go, yep, something broke, and that's it. Or they'll just throw the actual stack dump from, inside their app back to the client versus something that's a meaningful error message that's usable by the caller. And I think they really did well in this protocol with this. And I think it's something that we could all learn a little bit from. I also think that most of us realistically probably won't until, we suffer enough for not doing it. But look to some of the stuff that was done a long time ago and that underpins the web and underpins some of the big systems, because there's a lot of really good thought processes in there that you can steal and use for your own apps. And I think the error handling in HTTP is one that's pretty important and pretty useful. And the way that the handshakes work is another example. So that's what I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.